So here we go. We do need our unit circle. Specifically, we need our chart. And now you can use the unit circle at two different places. You can either use a chart or you can use the unit circle itself. But I'm going to use a chart. It's a little bit easier for me to read, and I have both sine, cosine, and tangent. We're actually going to solve these three equations here. The objective is to solve linear equations and trigonometric equations. Okay, and a trigonometric equation is simply an equation that contains a trigonometric function: sine, cosine, tangent, cotangent, cosecant, secant, whichever. The biggest thing we need to take away from this is you need to understand that to solve a trig equation, we use algebra to isolate the trig function to one side of the equal sign. So let's do that. We're going to kind of do that, jumping right into it. Just want to make sure this is recording. For the people that are absent today that are at the rally, the 8th grade rally. Whatever. It's okay. I'm not hurt. But a lot of people are going to be confused tomorrow because we're going to do some harder ones tomorrow, and I'm not slowing down. Even on Valentine's Day. Sorry. Yeah. Can I move on? Yes. This will be the last chapter. Chapter 7.6 is complex trigonometric functions. We don't do those. You probably do them in honors. And then 7.7 is vectors. Some of you guys did them in physics or doing them in physics. Again, we don't cover those. You'll do those, the dot product, magnitude, and calculus for those taking it. And that's pretty much that chapter. Everything else is using different parts of, there's a lot of them in there that I've never used even as a math major. They're good topics to cover, but I don't think we really need them. Or we're going to hold off from doing them. As if there wasn't enough stuff that you got to know for this one already. So, okay. So here we go. Do me a favor. Copy this down. And we're going to change up this bottom one. We shall make sense of this. Solving trig equations, the first thing we want to be able to do is isolate the trig function. We're going to find the solutions on the interval between 0 and 2 pi. It's a full rotation around our unit circle. Once we solve for x, set x equal to any of the solutions plus 2k pi or 2 pi k. And if it's tangent, we're going to just do k pi. There's actually infinitely many solutions because we have coterminals that correspond to these units. One full rotation is 2 pi. If we do another full rotation, it's 4 pi, 8 pi, 16 pi, 32 pi. So every single time we go around a unit circle, we can get a new function. And I'll show you guys what that means. These look super complicated, and you might freak a lot of people out if you never did this before. But we're gonna be able to use our charts here in order to help us out. And we'll discuss what that means. You have 5 homework problems today. Again, tomorrow I'm not giving you anything because it's the weekend. And I don't really want you guys to. We'll do practice problems. I'll give you practice problems today. And I'll probably grade it as you guys leave, but that's about it. Have you go over problems. Give you guys a worksheet for those that want to do that worksheet. Of course, bless you. Bless you. Can I move on? Yes? About 10 more seconds. Okay. Here's our first problem here. Okay. Copy down that first one. solving a trigonometric equation, solve the equation 2 times sine of x minus 1 is equal to 0. That's what we're going to do here. All of them have the same kind of setup, so they're all solving trigonometric equations. You can put this as example 1 or EX1, EX2. Abbreviate. Sounds like a Harry Potter spell. Abbreviate. No? Okay. Look, at least you're laughing. That's good enough for me. Right. So dumb, I get it. I can make you laugh, that's worth my while. Okay, here we go. What's my first step here? We're trying, how about this? What does number 1 tell us to do to solve? Isolate the trig function. What is my trig function for our example here? Sine of x. So let's get sine of x by itself. What do you think the first step to doing this? Add 1. So we're going to do that. And we're going to get this left side brought down. So we're going to get 2 times sine of x is equal to 1. And then what's my last step here? Divide by 2. Now, this is kind of the big finish for this. Sine of x is equal to 1/2. Okay. Now, this is not our solution yet. This is not our solution. What variable are we solving for? So the question we want to ask is what values for sine will be 1/2? Can you tell me what in radians, what would that be? So look at your sine chart. So hold on. Inside the sine chart, the first one that you come across is what? Pi over 6. Now, it's not just that little portion. Look at the whole thing. Is there any other time where sine is equal to 1/2? 5 pi over 6. These two solutions represent where sine of x is equal to 1/2. Now, we're almost done with our solutions here. Okay, we said number 2, we want to be able to identify where it exists in 0 to 2 pi. We found where it exists, in this case 5 pi over 6 and pi over 6. Number 3 tells me to do what? As soon as we find that value, what do we have to do? Add what? 2k pi or 2 pi k? You're always going to do that for sine and cosine. Because one full rotation plus pi over 6 gives you that same coterminal point. So in actuality, we have infinitely many solutions for any value of k that's an integer, whether it be positive or negative. Make sense? That would be our answer.
So when you write down, please put pi over 6 on 1 pi over 6 plus 2.
That is fine. I'm okay with that. Some teachers are not going to be okay with that, though. Just kind of remember that. So, I guess it's teacher's preference. Yeah, teacher's preference. But if you don't have this 2k pi, it is technically wrong. So I want that on your test. I'm going to require you guys do that. If you miss it, you're going to get like, if it was out of 4, you're going to get like half 0.5 of it off. Okay, it's important that it exists in there, and that's that first one. So that's all we're doing. Does that make sense? Here we go. Let's try another one here. Copy down this one. EX2 tangent squared x minus 3. Starting in about 10 seconds. Uh, 46, it's 34 minutes, 34. What's the variable we're solving for? Tangent. So we want you to get tangent by itself. What do you think my first step of doing this is? Add 3. So let's do that. Let's add 3 to both sides. we're going to get tangent squared x is equal to 3. How do we get tangent by itself if it's being squared? Square root to both sides. So this is going to give me tangent of x is equal to what? Plus or minus the square root of 3, specifically. Okay. Now, tangent can only exist between our intervals for our domain, so we're looking for the inputs that correspond with this. In this case, where is tangent equal to positive rad 3? How about that? Pi over 3 is another one. What about the negative ones? Now, the one thing that we want to be making sure we're understanding where these coming from, the charts that correspond to this also taken in rad. When we look at this, the values can only exist from our range from these values, right? So you guys already see that pi over 3 does exist, so this is a solution. What about 5 pi over 3? What would be its correct name for it? It'd be what? Negative pi over 3 for our value here, so this is a value. Does 2 pi over 3 exist in our domain? What about 4 pi over 3? So these are existing here and here, which are not solutions to the system. So we only have 2 of them that are representative here. Does that make sense? I don't want you to get too stressed out. If you can give me that, that's going to be good enough for me. Okay. Am I done with my values here, though? What am I missing? Plus 2k, or pi k, for our values. So we still take those into account when looking at our radians. So use those little blank areas to kind of help us determine those values. Does that make sense? Okay. And even in the previous one, we had it at, I believe it was 1/2 for 5 pi over 6, it would be negative pi over 6. But if you gave me them in radians, I would accept them because I'm okay with them. One question, what question again? It's a good question. We'll talk about that in a minute. Our solutions, can you have solutions that are not in there? Yes, you can. Will you? No. So if it doesn't exist on there, for our sake, because we're not an honors class, your sake, it should always be on the unit circle. So it's a great question. So if you have a question like this, let's say for some reason you solve out and you get tangent of x is equal to 1/2. Looking at your tangent at 1/2, does it exist on that unit, that part? Does it though? It does, but we can't find that solution. So I would just have you leave it there. In this case, you're always going to be able to find it. So don't freak out, okay? So here we go. Let's look at another one here. Solve for this one, okay? And what I want to be able to stress with you guys for this one is yeah, so we okay? Focus again. It's okay. Just want to be quiet. Okay. Can we solve this one out? What's my first step? Add 1 to both sides. We're going to get the square root of 2 times sine of x is equal to 1. And then do what? So don't even do that. Just divide it. Just solve it like that. Just divide it. Divide the rationals. Okay, you don't need a square because you're going to have to take the square root of both sides and there's going to be a lot more. You could do it, but it's not necessary. To rationalize the denominator, how do I do that in this case? Remember how to rationalize it? We'll have to multiply by. Not the reciprocal, but by its conjugate. Right? The conjugate of itself is just rad 2, right? Multiplying it by itself. For my solution here, I'm going to get radical 2 on the top. What's rad 2 times rad 2? Just 2. So my solutions for my case is going to be radical 2 over 2. Now again, for the sine function, what can my range be from? Pi over 2 and pi over 2, right? Negative pi over 2. So, right? For our domain or range, right? So what values is radical 2 going to be my solution for? Pi over 4 because it deals with my y. So pi over 4 and what's the other one? In this case, I'm going to say 7 pi over 4 because I don't mind you guys giving me for this one. But if we had to put it in the real context of things, it would be negative pi over 4. Right, for those two solutions. Are we okay with that? I would be okay with that. Again, there's a lot of stuff that you already have to worry about already. Right? Yeah. Because you're identifying the location values for these solutions. And technically, because the range values can only take on these values, it is technically negative pi over 4, but in the context of these, it's okay to put some pi. I'm okay. It's not technically correct, but I'm okay with you guys giving me that. Okay. So, am I done with my solutions? What am I missing? 2k pi. Is this easy or hard today, guys? Easy. Okay. We're going to amp it up just one more step. Okay, and I'm hoping we can see this. Okay. So let's look at this type of one. We're going to kind of skip that one. So we're going to kind of do this one. Copy this one down. I just amped it up quite a bit, but trust me, it's going to work out. 26 minutes. 26. Good? Good. Now, before I kind of continue this one, what I'm going to do is I'm going to split this up. And I'm just going to give you something, and hopefully you guys can kind of see where I'm getting at this. Let's say I wrote this way. How would you solve the one to the right? No. What do you think you have to do? It's factored. What do we do for the do now? Once it was factored form, what do we have to do to solve for it? Snowflake, and then we just set these equal to 0, right? Right, because we can use the zero product property in order for us to help us solve for these top values. If you're to solve the left-hand side, what would you get? Negative rad 3 over 2. And the other one would be what? 1/2. Okay. Consider these factors to the left-hand side as well. These make it no different that we have two factors using variables of cosine and sine. So because these are two factors, we can use a zero product property to identify what the zeros are for this. So what we're going to do is we're going to set this equal to 0. These are just factors, right? Set that equal to 0. 0. If we solve out the left-hand side, it's very similar to the right side equation. We're going to get cosine of x is equal to negative rad 3 over 2. And sine is 1/2. Multiple solutions for our case in this part. Can you tell me the values for when cosine is negative rad 3 over 2? 5 pi over 6 is definitely one of them. Is there another one up there? 7 pi over 6. Looking for the solutions for us. On the unit circle, can 7 pi over 6 be a solution for us? Where does the range exist for our 0 to pi, right? 0 to pi. So can 7 pi over 6 exist? So we don't really need this one, do we? What about for cosine? When is cosine equal to 1/2? For what values? Pi over 6. Is there another one? That's negative. 5 pi over 6. When is sine 1/2? And 5 pi over 6, right? Because this 11 pi over 6, the sine is negative 1/2. This is positive, right? This is not negative, this is positive. But can 5 pi over 6 exist in our range? So we only still have only 2 solutions for this. What am I missing between both of them?
So in this case, instead of being columns, you want to separate it.
You could put them together. Still, do it the same method you have it. I'm okay with that. I'm okay with that. I'm just trying to show you that I'm solving separately, right? So yeah, they make the same. Yeah, you're still okay. Is what I want to tell you. Okay, I'm okay with that. Still okay? So given factors, we can still solve these. So looking at the objective today, it still says solve for linear, which we solved in the beginning. Now we're looking at quadratic. So this is the last one we're going to do, and we'll cover more of them tomorrow. Okay, copied on this one. The one thing I want you guys to identify is cosines, again, can only exist between these parts. I have one of my hairs on my this. A beard hair. I was going to shave it off the other day too. I was like, do it. I was like, no, because I regretted it the last time. Okay. Let's say when you look at this, you're like, I don't know what to do to solve for this. So what we're going to do is what's called substitution, trig substitution. We're going to substitute u for a substitute. You can make it any variable for cosine of x. It's kind of the key one here. Now, the more you get, the better you get at this, the less you have to do the substitution because you're going to start seeing these. If we treat sine and cosine like variables, it makes no difference of applying them. So wherever I see a cosine, I'm going to replace that with u. So this will be 2u squared minus 7 times u plus 3 is equal to 0. Now, in this kind of context, what do you think we have to do in order to solve out? Not combine like terms. Snowflake, what is that called? Factoring. Now, this is why we want to be able to do the do now. Does this follow the exact same one for the do now? So can you automatically tell me what the factors are? This is from the do now here. give me the factors. 2x minus 1. What was the other one? So these are the factors. These are very similar to what we've been doing. And we're still going to solve out for u. U is going to be equal to 1/2. And u will be equal to 3. Okay. Now, what we want to be able to reference this back with is we still have this little substitution. So we got to always plug it back in if you want to do it this way. So u becomes cosine. So when is cosine of x equal to 1/2? And when is cosine equal to 3? There's a question that Mr. Romero had earlier that's going to deal with what you had, the question you had earlier. For cosine of 1/2, for what values is cosine 1/2? So cosine is going to be pi over 6 is our cosine, right? Pi over 3, sorry. Cosine deals with what variable? X, determine a point for x. What about, is there any other one? Is 2 pi over 3 positive or negative? So is that our solution? 5 pi over 3. 5 pi over 3 is correct, but is that in the range? Is, in this case, it's down below here, which doesn't exist, right? So the other question to ask is, what about this cosine of x equal to 3? Right, first of all, can we find it on our unit circle? What's the maximum cosine can be? 1. So it's definitely not even possible to even find the inverse of it because it's not even possible to find it on our unit circle. So this pretty much goes away. What's my solution for this then? Pi over 3? Easy or hard today? That's it. That's it. We're going to practice this tomorrow. I want to say you have something like this on your test, where I'm going to ask you to factor, solve, tell me where they exist. Cool with that? Ooh, cool beans. Here we go. If you guys want to copy these ones down, no, just practice. So if you want to take a picture of, if you guys want to practice these, you guys can. I'm going to give you guys some homework. Again, the bottom one is factoring. The other one, sine and cosine for A and B. So looking at those values. We should get the top one where cosine is equal to negative 1/2. And 4 pi over 3 is negative 1/2, but cosine doesn't exist. So that solution is technically not true. But I'm not going to like trip about it. Okay, so here we go. Can I move on? Okay, here's your homework for you guys. Not all of them. Not all of them. Try this one. I'm gonna give you this one. 1, 2, 3, 4, 5. Just 5 problems here. Easy enough? Okay, we're going to practice this more tomorrow. You still have 14 minutes. 14 minutes. So go ahead and get started.